So 12.3 is about solving logarithms. You might have to solve an exponential equation, or you might have to solve a logarithmic equation. We'll look at both of them. And basically, if you have a log equation, you're going to use exponents. If you have an exponent equation, you're going to use logarithms. So if we look at our first example, we have 2 to the x equals 5. Now, I don't know 2 to what power gives me 5. It's going to be some kind of decimal. So we actually have two different ways we can go about this. Notice that the base of my exponent is 2. And so if you remember, when we talk about Tetris effect, we talk about log base, and then if both the base of the logarithm and the base of the exponent are the same, we have Tetris effect. And so we can do that here. I can create Tetris effect. I'm going to take the log of both sides. So this right here, by the way, this is an exponential equation. So I'm going to use log. I'm going to use the opposite to help me solve it. So I'm going to go log base 2 of 2 to the x, and then on the other side I take log base 2 of 5. Now I've taken the log of both sides. As long as you do on both sides is a legal step. And now I have the base of my logarithm and the base of my exponent the same. So I've got Tetris effect, and x equals log base 2 of 5. Now a lot of times when you're solving an equation, you want more than just log base 2 of 5. You actually want to know what is this as a decimal. And so since your calculator can't do this, you'll have to use the change of base formula. So we'll go log of 5 over log of 2, and now you can plug that in your calculator and get whatever that is. There's another way to do this. If I have 2 to the x equals 5, and I don't want to bother with log base 2, because as I think ahead, if I have log base 2, I'm going to have to use a change of base formula, then instead I could go, you know what, I'm going to use log base 10 just right off the bat, since I can use my calculator. So log base 10 of 2 to the x equals log base 10 of 5. Now what that doesn't do for you is now we can't use Tetris effect because the bases aren't the same. The base of my logarithm is actually 10 and the base of the exponent is 2, so I can't use that. But what I can do is use my properties. Remember, my properties says if I have an exponent, I can bring it down in front. And so now I have log x times log of 2 equals log of 5, and then I can divide both sides by log of 2. And so we have x equals the same thing as what we had before after we used the change of base. So either way it works that you can do that. Now another type of equation would be, what if you got a log equation to start off with? So what if you had log base 2 of x equals 3? So now I have a logarithmic equation. So now it doesn't help to take the log of both sides. What I'm going to do is I'm going to do something called exponentiate. What I'm going to do is I'm going to make each side the exponent of the same base. And since I've got base 2 here, I'm going to use 2 as my base number. So what I mean is I have my 2 as my base number, and then I'm going to take all of this, and that is now going to be my exponent. Equals, and then I have to do the exact same thing on the other side. So 2 is my base number, and now this is my exponent. And if you remember, this also is Tetris effect. When I have the base of my exponent and the base of my logarithm the same, my answer is what's inside the logarithm. And then 2 to the third is 8. So I found my answer that way. So if you already have a log, then you want to exponentiate. And then it can get, of course, complicated. So here is an example. If I have log of 5x plus log of x minus 1, it'll equal 2. So now I have 2 logs, and so before I'm going to want to exponentiate on this one eventually, but before I can do that, I first want to get it down to 1 log. So if you remember in my properties, a plus means that I'm going to take what's inside both of them and multiply. So I want to write it as 1 log first, and that's often a mistake people make, is they go straight to exponentiate. But no, you want to get 1 log first. Now I can exponentiate. The base of my logarithm is 10, so I'm going to use 10 as my base here. So now it's 10 to the log of that stuff and 10 to the second. Now I have Tetris effect here, so we get 5x times x minus 1 equals 10 squared is 100. Multiply through by 5x. Move the 100 over. And then I can factor out a 5. So now I'm looking at that I have a quadratic. If you see here, I've got a quadratic that I have to solve. So I've got a double bubble. First I'm going to factor out a 5 though, so that it's a little bit easier. And so I have 5 times, and if you box this out, So you can go over here and work it out if you want. If you box it out, it's going to be a 5 and a 4, negative 5 and a positive 4. And then I take them and I set them equal to 0 separately. Oops. Okay, and if I do that, I add 5, x equals 5, subtract 4, x equals negative 4. Okay, the only thing you have to be worried about with this is once you have those answers, so I have x equals 5 and x equals negative 4, I have to make sure, remember logarithms cannot have a negative inside the log. So if I take that negative 4 and I plug it in here, you'll notice 5 times negative 4 is negative 20. And I can't have a negative inside the logarithm. So negative 4 is not going to work. If I take that 5 and I plug it in, 5 is fine because I get 25. That's a positive number. And if I plug in 5 there, 5 minus 1 is 4. And that's also a positive number. So I'm perfectly fine with that. I can just leave that as x equals 5. So that's my only answer on that one. Let's look at another example. I know a lot of times people get uncomfortable when they see natural logs, so let's do an example with natural log. So here, once again, I'm going to want to exponentiate, but before I do that, I need to take care of this minus right here. And remember, minus means divide. So I still have the natural log of x plus 5 on the left. On the right, I'm going to have natural log, and then I'm going to have x minus 1 over x plus 1. Okay, now that I've done that, I can exponentiate both sides, only now I'm going to use base e, because if you remember, the base on the natural log is e, and I want to use the same thing. So then we've got Tetris effect. So we've got x plus 5 equals x minus 1 over x plus 1. In order to solve this, I want to get that x plus 1. Oh, there's a couple ways we could go, but you know, why don't we do this? Why don't we make this a proportion? So I'm going to multiply these together. So we get x squared plus 6x plus 5 equals, and then over here I get x minus 1. I'm going to move those over. So now I can double bubble. Okay, and if I double bubble those, I get x plus 3 and x plus 2. Now when I solve that, I get x equals, I'm going to set them both equal to 0 and solve, I get x equals negative 3 and x equals negative 2. Now once again, you need to double check that that doesn't make it a negative somewhere. And so if I just focus in just on this one alone, if I plug in a negative 3, that gives me negative 4. So I can't have that because then that would make this a negative inside the natural log. So that one's done. And if I take the negative 2 and plug it in, that'll make it a negative 3, and I still can't have that. So this one actually has, even though we found two things, this one actually has no solutions because both solutions are called extraneous solutions since they both didn't work when we put them back in. So again, when you're solving, if you have an exponential, then you need to take the log of both sides. Look at the base, decide if you want to go base 10 or do you want to go base 3 here. If you have a logarithmic, then what you want to do is you want to exponentiate. You want to take and make that the exponent of the base that you see in the log, and then you can finish solving.